In a world where lines and angles reign supreme, circles bring a curveball of intrigue and complexity. Today, we're diving into the captivating realm of circle theorems, a cornerstone of geometry that lends itself to countless real-world applications. The first theorem that we'll explore is an absolute classic. The diameter subtends a right angle to any point on the circle. What this means is that if you draw a line from one end of the diameter to any point on the circle's circumference, that line will always form a right angle with the diameter. Simple, isn't it? Moving on to the second theorem. Angles in the same segment are equal. If you draw two lines from the same segment to the edge of the circle, they'll form angles at the circumference. No matter where you place these lines, the angles they create will always be the same. This theorem is a testament to the symmetry and consistency inherent in circles. Next on our list is the theorem stating that the angle in a semicircle is a right angle. If you draw a triangle in a semicircle with the diameter as the base, the angle at the circumference will always be a right angle. This theorem is an interesting variation of our first theorem and further emphasizes the magic of the right angle in circle geometry. The fourth theorem we'll examine is that the angle at the center is twice the angle at the circumference. When you draw two radii of a circle and join the endpoints to form two angles, one at the center of the circle and one at the circumference, the central angle will always be twice as large as the angle at the circumference. This theorem is particularly fascinating as it reveals the proportional relationships between different parts of a circle. Last but not least, we arrive at the theorem which states that opposite angles in a cyclic quadrilateral sum to 180 degrees. If you draw a four-sided shape inside a circle, the opposite angles of this shape will always add up to 180 degrees. This theorem beautifully ties together the concepts of circles, angles, and quadrilaterals. In summation, circle theorems reveal the intricate and consistent relationships between angles, lines, and circles. We've seen how the diameter subtends a right angle to any point on the circle, how angles in the same segment are equal, how the angle in a semicircle is a right angle, how the angle at the center is twice the angle at the circumference, and how opposite angles in a cyclic quadrilateral sum to 180 degrees. Circle theorems are an integral part of geometry, and they offer a fascinating insight into the mathematical order of the universe. With their help, we can solve complex problems, design intricate structures, and even navigate the stars. This is the magic of geometry, the magic of circles, and the magic of mathematics.